Identifying exponential functions. Let's determine whether the given function is linear, exponential, or neither. If the function is linear, find a linear function that models the data. If the function is exponential, find an exponential function that models the data. So here's a table of x and y values. What we need to first do is calculate the average rate of change of y with respect to x. So between the first and second rows, we need to calculate the change in y over the change in x. 2 minus 5 over 0 minus negative 1, which is negative 3. Let's look at the next two rows. So rows 2 and 3. We have negative 1 minus 2 over 1 minus 0, which is also negative 3. Rows 3 and 4, negative 4 minus negative 1 over 2 minus 1, which is also negative 3. And our last two rows, negative 7 minus negative 4 over 3 minus 2, which is also negative 3. If the average rate of change is constant, then the function is linear. And the average rate of change is the slope. So we have a slope of negative 3. Now, notice, we have this row where we have x is 0 and y is 2. This is telling us our y-intercept. So b is 2. So in the equation y equals mx plus b, we can replace m with negative 3 and b with 2, and we get y equals negative 3x plus 2. Okay, let's look at another table. So let's again start by calculating the average rate of change. So here we have 16 minus 32 over 0 minus negative 1, which is negative 16. 8 minus 16 over 1 minus 0, which is negative 8. 4 minus 8 over 2 minus 1, which is negative 4. 2 minus 4 over 3 minus 2, which is negative 2. These are not the same, so it's not linear. Okay, next, calculate the ratio of consecutive outputs. So if I look at 16 over 32, I'm looking at my y values, 16 over 32, that's 1/2. Looking at the ratio of the third y to the second y, 8 over 16, it's also 1/2. 4 over 8 is 1/2. 2 over 4 is also 1/2. If if the ratio of the consecutive outputs are the same, then the function is exponential. So the ratio of consecutive outputs is the growth factor, which is my b. So b is 1/2. We have a row where x is 0, y is 16. So this is telling us that a is 16. That's our starting value. So y equals a times b to the x becomes y equals 16 times 1/2 to the x. Okay, let's look at one more table. Let's start again by calculating the average rate of change. So 4 minus 2 over 0 minus negative 1 is 2. 7 minus 4 over 1 minus 0 is 3. 11 minus 7 over 2 minus 1 is 4. 16 minus 11 over 3 minus 2 is 5. These are different, so it's not linear. So let's calculate the ratio of consecutive outputs. 4 over 2 is 2. 7 over 4 is 7/4. 11 over 7 is 11/7. 16 over 11 is 16/11. These are all different, so it's not exponential. Okay, let's look at another type of example. Here we have a graph. Let's determine the exponential function whose graph is shown here. Okay, well, we have 3 points on this graph identified for us, And it's not going to be any different than if these were points in a table. So I've got negative 1 comma 4, 0 comma 1, 1 comma 1/4. So let's look at our ratio of outputs. So I have 1 over 4, 1/4 over 1, which is 1/4. So my ratio of consecutive outputs is 1/4. That's my B. When x is 0, y is 1, so A is 1. And y equals a times b to the x becomes y equals 1 times 1/4 to the x, or just y equals 1/4 to the x.